Hey, welcome to this Rhino tutorial. Today we'll be talking about user interface. First, let's start up Rhino. Now, when you start Rhino, you'll see a window like this, and there are these template files over here. You can make your own template file, which we'll cover later, but here it comes preloaded with a bunch of templates using different units. We'll go over how to change these units, but for now, let's start with large objects, inches. So when Rhino opens up, you'll see an interface like this. You have multiple bars of menus and different options. The main parts that you're going to be using are these viewports. So perspective, top, front, and right. To increase the size of any of these viewports, just double click on their name, and that will full screen it, and then double click again to go back to this view. If you're using Mac, you'll also have this little bar up here where you can do the same thing by selecting these icons. So full screen and then all four viewports, and you can cycle between them up here as well. So the first thing that we want to do when we open our Rhino file is save this file. So we're going to go to File, Save. We're going to save as UI. User Interface Tutorial. And we're going to save it to Documents. And now our file is saved. So it's really important to save your work frequently with Rhino. It does have an autosave feature, but this autosave feature isn't the best, and it's very common that Rhino can crash while you're doing more complex commands. So I would highly suggest saving frequently. And you'll notice that I'm using a keystroke tracker here in the bottom left. So when I type and write commands, you will see all of that. So if I hold Shift, this will light up. If I hold Command, this will light up. So even when I'm doing hotkeys and those kinds of commands, you'll be able to see what's going on. Before we start talking about any of these panels of the user interface, we're going to cover movement quickly. There are several different ways to move the camera in Rhino. The one that you'll be using the most often is orbiting. So right click and drag to orbit around your model. Alternatively, you can hold Shift, right click and drag to pan, just moving side to side. It's worth noting that in your top, front, and right views, you can't orbit. So if I were to just right click, not holding Shift, just right click and drag, it would pan. Use the scroll wheel to move in and out, and you'll be using a combination of all of these techniques to move around in your model. Now it's worth noting that once you start panning a lot, the center of what you're orbiting changes. So whereas before I was orbiting around the origin, now I'm orbiting around a point that's kind of out here. So that can be a problem later on, and I'll show you what I mean. If we come over here and make a quick rectangle, and I want to draw some lines on this rectangle, and I'm looking around to try to get the best angle to draw, but say, I panned over here, and now I want to get over to this rectangle, and it's kind of hard to look at it. I zoom in on it, but when I orbit, it just goes away. You can type ZS into the command line, and you can do this just by typing. You don't have to move your cursor over to the command line. You can just start typing, and it will automatically go into the command line. But ZS stands for Zoom Selected. So we're just going to type ZS, hit Enter. You can either hit Enter or Spacebar to confirm the command. And now that we've done that, you can see we are snapped to this object, and when we rotate, that object will be the center of our rotation. So I'm going to delete this object quick, and now we can start talking about the user interface panels over here. So let's start by talking about this panel here. This is your Properties panel. And when you don't have any geometry selected, it's going to show you the properties of the viewport that you have selected. So if I go into Perspective it's going to tell me a bunch of information about the perspective viewport. If I go into right view, it's going to tell me everything about right view. So you'll notice that by default, right, front, and top view are all parallel projection, and then perspective is a perspective projection. You can change these things at any time, but for now I would recommend keeping them as they are. In this window, you'll be able to choose your lens length and all the camera parameters. The panel right below this one houses a bunch of different features that we'll go through one by one. The first one selected here is layers. We can drag the name of these layers out. We'll pull this panel out a little more so we can see what we're working with. So each of these layers has a unique name. You can name them whatever you want by double-clicking on the layer. This layer I'm going to name Geometry, or Geo for short. And this layer I'll name Curves. And I can reorder these layers by clicking and dragging. I can also nest these layers inside of each other by clicking, hovering, and now we have a nested structure. This blue dot here shows which layer is active. So when I type in certain commands, those commands can create geometry, and those different geometries that I'm creating will be created on whatever layer is active. So I don't want to use default right now, so I'm going to go to curves. We'll make some curves. And if I go over here, make a curve, you can see that that curve is being made on the curves layer. The curves layer is purple, and my curve is also purple. I can change the color of the curves layer by coming over here and choosing whatever color I want. We'll choose maybe this dark blue. I can hide and toggle different layers with this feature here. So if I'm working on the geometry layer and I no longer want to see my curves, I can click this little light bulb and it hides the curves layer. It's also important to note that it hides any layer that is dependent on the curves layer. So since layer 3 is nested under the curves layer, it will also hide layer 3. That being said, I can choose to just hide layer 3 and keep curves not hidden, but if I hide curves, it will automatically hide layer 3. This is the same for locking. So right now I can select this geometry, but if I want to lock it, I just press this, and now the geometry can't be selected. We won't go over line type and print width right now. That information will be covered in the 2D series. So let's head over to display. So in the display pane, you can choose from a bunch of different options on how to display whatever geometry you're looking at. If I bring out some solid geometry, right now, since we're in wireframe, everything will show up as a wireframe. If we switch to shaded view, we'll get a better understanding of what this solid looks like. It's important to note that the changes that I'm making to the display settings here will only show up in whatever viewport that I'm working in. So while I've changed perspective to shaded, all the right, front, and top views are still in wireframe. I can also use this window to show or hide specific categories of geometry. So say I no longer want to see curves in perspective, I can come over here and deselect curves, and then it won't show any curves in perspective. So those are the two most important features here in this panel, layers and display. The rest we can cover later, but they're not really important to start. So let's move over to object snaps. So this window over here is the object snap window, and object snaps are critical to modeling things accurately. So by default, I usually turn on most of my object snaps. And if ever you want to disable your object snaps, you can just click Disable All to temporarily disable them. What object snaps are useful for is aligning things properly. So if I were to make a line, I'll type line, and say I wanted to make a line to this endpoint here. You'll see end and intersection pop up. That tooltip is telling me that when I make this line, it will be connected to the end and intersection points. So let's go ahead and make that line. Now, if I try to do that again with my object snaps disabled, I'm going to create a line just like before, and I'm going to start it here and then try to attach to this. So if I get as close as I can, probably something like that looks pretty good, but you can see that they're not actually touching. So object snaps are extremely useful for getting things to line up correctly, especially as you move from 2D to 3D. You want to make sure everything is lining up correctly. If things don't line up correctly, this will make commands like curve boolean, hatch, planar surface, any of the surface creation commands, it will make them very difficult to use. So now that we've covered object snaps, we can take a look at this top bar here. That has grid snap, ortho, planar, all of these. So we'll go through those one by one. Grid snap is just what it sounds like. It makes sure that all of the geometry that I'm creating snaps to the subdivided grid here. So you can see that as I'm creating this point, that point, as I move my cursor, is snapping to all these little grid lines. That's pretty useful if you know that what you're designing should be a subdivision of whatever unit you're working in. However, I don't often use this because things that I make are a little more freeform, so I usually have grid snap off. The next one is ortho. So ortho stands for orthographic, and ortho, when you have it selected, will constrain your geometry to the cardinal directions in the Rhino file. So when I create this line, when ortho is on and I draw this line, it will snap either up, right, left, or down, which is pretty convenient. But if you want to toggle ortho on or off, you can hold shift, and now I can draw anywhere. So by holding shift, I'm toggling ortho off. You can see up here that it gets unhighlighted, and then when I let go of shift, it comes back. The same is true when ortho is off and I want to turn it on. So I made my ortho line. I'm going to turn ortho off now, and I'm going to repeat this polyline, right click and repeat polyline. Now that ortho is off, I can hold shift to turn it back on temporarily, and then I'll let go of shift if I don't want it. So we're not going to cover planar. Next thing we'll talk about is Smart Track. So what Smart Track is useful for is, say I have some geometry and I want to project this line out, but I don't really want to draw another line. I can use Smart Track to trace the length of this line and then project it out. So I know I want to draw something that is in line with it, but starts over here, and then I can start drawing. And you can see Smart Track will come back and give me that reference line, which is pretty useful. The next thing we're going to talk about is Gumball. And Gumball is kind of just like a quick and dirty user interface that you can use to move, scale, rotate your basic transformation commands. So when I select this box, this little tooltip that pops up is the Gumball interface. You can see that there are arrows, arcs, and boxes and planes, a whole bunch of stuff. The color of each of those relates to the different cardinal directions in Rhino. So green is our Y, red is our X, and blue is our Z. So let's start with the arrows. So when I mouse over these arrows, you can see that they get grayed out. I can click and drag on these arrows to move this geometry in whatever direction I'm selecting. I can also click without dragging and type in a precise amount to move them. So say I want to move this 5 in the X direction. I type 5, hit enter, and then it moves. So that's how you move things with the arrows, but you can also move things with this plane here. So when I mouse over this plane, I can move it both in the Y and in the X, but it's constrained in the Z. So it's going to stay in the same place in the Z, but be moved in the Y and X, like that. You can also move with this little point here, and this point is moving all axes at once. So if you look over in my front view, you can see that over here, that you can see that it's no longer constrained in the Z direction, and I can snap to any of these points, but it is worth noting that moving it by this point will always be the centroid of whatever geometry you're selecting. And another quick note about these planes, if you don't see the plane that you want to move in, so right now it's only displaying the X and Y plane. If I want to move in the Z and Y plane, I have to orbit over until that plane pops up. And now I can move in Z and Y. So the next part of the Gumball interface is the rotation commands. So we have these little arcs, and just like the arrows, we can click and then drag on the arcs to spin the geometry. We can also click and then precisely type a unit measurement. So let's say I want to rotate 90 degrees, hit enter, and I can rotate 90 degrees. Your Gumball interface is by default bound to the cardinal directions of your Rhino file. So when I click off this geometry and click on again, these Gumball directions are now aligned with your construction plane and not with your geometry. So when you change your geometry, the Gumball interface won't reorient with it by default. The last part of the interface that we're going to talk about is scaling. So you can see these little boxes opposite the arrows, and these boxes will scale your geometry in whatever direction you pull them in. It's worth noting that you can hold down Shift here to uniformly scale, even if you're only selecting one direction. This little circle here is the Gumball options. You can click this circle and then choose from a number of different options. You can reset Gumball. You can align it to your object, world, any of these options. So if, say we wanted to relocate the Gumball, we would click this, and then it's going to ask us for the origin of Gumball, and then it's going to ask us for the X direction here, and then the Y direction there. And now our Gumball is oriented to that part of the object. One thing that I forgot to mention about rotation is it works in a similar way to scaling where, say I'm just clicking and dragging this, I can hold Shift to lock into those quarter rotations. So that's Gumball. It's pretty convenient for moving things around. There are other commands that can do this. Rotate, move, all of those commands that you'll find in the command line. Those commands will have more options for how to move things, what points to reference as you're moving those things. Gumball is kind of just a quick and convenient way. As you're modeling, you'll probably run into some situations where Gumball won't cut it and you'll need to use the other move commands. And in this tutorial, we're not going to cover history. So that's it for this top deck. We're going to quickly go over the command line and the commands that you see over here on the left. These commands are a limited selection of all of the commands in Rhino. Rhino has many commands, and they can't all fit in this window. So these are some of the most common ones. It's worth noting McNeil, the company that makes Rhino, has an online repository of all the commands that you can use in Rhino. It's pretty easy to find. We're just going to go to Google and type in Rhino commands. if I can spell. And it's this first link that comes up, docs.mcneil.com. So this has all of the commands in Rhino. It's definitely worth taking a quick tour of these commands. It can be a bit daunting to look through all of them, but one of the reasons why I like to use the command line over these command buttons is because if you think a certain command should exist, say you want to move something, but you don't see any icon here that looks like it would move anything, if you just type in move, there is a command for that. While there won't always be a command for exactly what you want to do, it's definitely worth trying to type it into the command line first and seeing if there is. Next best option would be going to the McNeil website and seeing if you can find what you need. If that doesn't work, I would highly recommend searching through the Rhino forums or YouTube tutorials similar to this one. And that's it for user interface. In the next lesson, we're going to cover basic 2D, geometry creation, and movement, and we'll see you in the next tutorial.